The inspector window provides us with tools and information that help us troubleshoot a network node or a link. Let's check a device inspector window. We can see it contains 3 parts. The first part includes basic device information like device name, router type, and serial number. It's followed by device availability during the selected time frame and the number of static routes and interfaces on the router. Below, there are several buttons. Let's review what they do. Drill In takes us to the device context page. Here, we can find device details, various device and link availability performance graphs, health information, and an alerts section, which displays events related to the device. Next is the SSH button. Pressing this will initiate an SSH session to the device. The Start Route button highlights a path on the topology map. If we choose this option to set the path source, then the inspector window of the second device will show an End Route option instead of Start Route. We can use this to set the path destination device and highlight a path through the network. Sometimes, when we make changes to the routers, like adding a static route, the changes are not immediately picked up by the collector. If we want to update the changes immediately, we can use the Collect Now button. Pressing the Hide button removes the device and all links associated with it from the topology map. Last part of the inspector window is routing information and technologies associated with the router, such as IGP areas, router details, tunnels, BGP information, Layer 2 and Layer 3 overlay services. Extending each entry provides us with more information about the technology and links to events pages that display events for different time periods. Let's see how we can use the inspector to investigate a customer complaint. A customer is reporting that just before 1 o'clock in the morning, their service between New York and Dallas went down. We narrow the location of the failure to a link between 2 backbone routers. Let's use the inspector window to check the context page of the device involved in the incident by opening the device inspector window and pressing the Drill In button. We can see that the OSPF backbone link between New York and Dallas has some downtime. Let's go back to the topology map and check the events that are available through the inspector window for that link. Click on the OSPF backbone area section. There are several hyperlinks available which go to event pages for different time periods. Let's click on the 1 hour link and see the events related to the backbone area in the last hour. All events are displayed with a microsecond timestamp accuracy. We can see that the link went down at 48 minutes past midnight, causing the OSPF adjacency to break between the routers. This concludes the inspector window overview.